Hello. Today I present to you the construction of a small astronomical instrument similar to the quadrant used in maritime navigation. This device uses the reverse principle. That is, it indicates the position of the North Star, Polaris, depending on position and latitude. The device also works during the day or in cloudy skies, even if the star is not visible. The North Star is positioned exactly above the North Pole. A person in this place will see the North Star at an angle of 90 degrees, more precisely above the head. As we move away from the North Pole towards the equator, this 90-degree angle will decrease towards zero. The device works only for a user located in the Northern Hemisphere. The North Star is not visible from the Southern Hemisphere. The angle of Polaris above the horizon at a particular latitude is equal to the observer's latitude. This means that if you are at a latitude of 40 degrees north, Polaris will appear 40 degrees above the northern horizon. We need a device that tells us the latitude, the north, and the correct position in relation to the horizon to find out the exact position of the Polaris star. This is exactly what this Arduino device does. How does the device work? A compass module and an accelerometer module will indicate the north position and the correct position relative to the horizon line. A Neo 6M GPS module will read the exact latitude of the user. This value represents the value of the angle at which the pole star is positioned. We need some components: an Arduino Nano controller, an HMC 5883L compass module, an MPU 6050 accelerometer module, a Neo 6M GPS module, 2 LEDs, 2 resistors, a push button, a buzzer, and an SG90 servo motor. I did some tests on a breadboard, and at the end I mounted all the components in a plastic box. Pay attention to the positioning of the compass module. Mount it as far as possible from any part that can be magnetized for a more precise indication. The device requires a few simple steps for calibration. Press the push button connected to pin D8. The device will enter the calibration mode. The servo motor will change its position every 2 seconds from 0 to 90 degrees. Change the position of the indicator on the mobile wheel to correspond exactly with the two values. Press the button again. The device goes into accelerometer calibration mode. Position the device parallel to the surface of the Earth. Adjust the position of the MPU 6052 accelerometer module until the red LED stops flashing and stays on permanently. With this, the calibration operation is complete. The device only works outside buildings. When the satellites are received, at least 3, the blue LED starts to flash. Turn the device clockwise or counterclockwise. As the device approaches the north position, the LED will blink faster. Turn gently until the blue LED stays on. Maintain the position facing north for 5 seconds with the blue light on. If you hold the device for 5 seconds with the blue LED on permanently, the servo motor will move exactly to the position of the Polaris star. Raise the device to eye level. Look exactly in the direction indicated by the arrow of the servo motor. Gently move the device until the 2 LEDs, red and blue, remain permanently lit as much as possible. On a clear night, you will have to see the North Star located in the Little Dipper. The code. The code is built in Visuino, a program with which you can develop projects with just a few mouse clicks. See in the description all the details related to this project, as well as other channels with interesting projects with Visuino. You can also find the code in IDE format. We load the code in Visuino. We observe the 3 modules and the Arduino controller. The compare unsigned value component is set to 3 or higher. That is, when the device receives a minimum of 3 satellites, it is ready for operation. The compare analog range component establishes the accuracy of the device. It is set to a value from 2 to 358 degrees. As long as the device is positioned between these values, the blue LED will light up permanently. You can increase the precision to 1 degree, changing with a minimum of 1 and a maximum of 359 degrees, but it will be more difficult to handle. The analog map component sets the stroke of the servo motor. You can adjust the minimum output value in certain cases if the indicator's stroke goes out of the 0-90 degree limits. Choose the correct port and upload the code to the Arduino.